Open loop transfer function of system. Open loop transfer function of the system. We know the open loop transfer function of the system, that is the GSHS. In the question given that open loop transfer function of the system is given by S into S plus 1 into S plus 3, and where value of k is greater than 0 and less than infinity. This is mentioned here. Means value of k greater than 0. If value of k greater than 0, this generally we consider this is the negative feedback. We'll explain it. And question asked, draw its root locus and we got find the value of gain margin. What is the value of gain margin at k is equal to 6? This is the question. Means we have to draw root locus and also find the gain margin of the system, and value of k is equal to 6. Now see what is the importance of this part here. First of all, discuss this. Say that k is greater than 0 means k is always a positive quantity, and this will be only happen for negative feedback system. Means this open loop transfer function of a system, when we are going to design a root locus, then we consider the feedback of that system is negative feedback. If the value of k, if maybe some questions they say the value of k is, this is the range of value of the k. If in the question, if the in किसी question में अगर k value of k is not given, then we assume that k is always greater than by default, right? But अगर किसी question में given होगा नहीं k की value minus infinity से 0, तो यहाँ पे हम इसको consider करेंगे this is the positive feedback system. Generally most of the exam में ये इस part पे भी कोई question नहीं आएगा. सारे क्वेश्चन हमारे जो होंगे, जो हम इस वीडियो में सॉल्व करेंगे, मोस्ट ऑफ द क्वेश्चन यहाँ पे होंगे, बट कुछ क्वेश्चन हम पिक करेंगे जब k की वैल्यू माइनस इन्फिनिटी से 0 के बीच होगी. तो रूट लोकस में क्या चेंज होगा? सेम क्वेश्चन में अगर इसी क्वेश्चन में k की वैल्यू को माइनस इन्फिनिटी तो 0 में करूँ तो रूट लोकस कैसा होगा, उसके बारे में भी डिस्कस करेंगे, राइट? तो पहले हम डिस्कस करते हैं कि k की वैल्यू 0 से ग्रेटर देन है, इन्फिनिटी से लेस है, मीन्स इस क्वेश्चन में गिवन है, उस पॉइंट को हम डिस्कस करते हैं. नेक्स्ट वीडियो में हम इस टॉपिक पे डिस्कशन करेंगे. क्लियर? आई नीड सम 1 सेकंड. हम डिस्कस करेंगे कि k की वैल्यू माइनस इन्फिनिटी से 0 होगा तो क्या होगा और पॉजिटिव फीडबैक किस तरह से कंसीडर करेंगे. बट यहाँ पे हम किसको कंसीडर करने जा रहे हैं? k ग्रेटर देन, जैसा क्वेश्चन में गिवन है. हम अभी यहाँ पे सिर्फ क्वेश्चन जैसा गिवन है उस पॉइंट को डिस्कस करेंगे. बट आने वाले वीडियोज में हम ये भी डिस्कस करेंगे k की वैल्यू नेगेटिव हुई तो क्या होगा, सिस्टम के रूट लोकस पे क्या इफेक्ट पड़ेगा. नाउ सॉल्यूशन ऑफ दिस प्रॉब्लम. हमने क्या कंसीडर किया, सिस्टम क्या नेगेटिव फीडबैक है बस, और उसके लिए सारे फॉर्मूले हम यूज करेंगे जो हम इंट्रोडक्शन में, जो भी हमने इंट्रोडक्शन में मेरा वीडियोज है उसमें ऑलरेडी मैंने डिस्कस किया है इसके बारे में. नाउ फर्स्ट ऑफ ऑल वी हैव टू फाइंड व्हाट इज द पोल ऑफ द सिस्टम. व्हाट इज द पोल ऑफ द सिस्टम? जस्ट राइट व्हाट इज द पोल्स ऑफ सिस्टम. Poles of the system located at s is equal to 0, s is equal to -1 and s is equal to -3. S is equal to 0, s is equal to -1, s is equal to -3. This is the location of the pole. What is the location of 0? What is the location? Is there any 0 in our question? No. Means there is no 0. No 0. But if there are no 0, we assume that there are 3 0 at infinity. We assume that there are 3 0 because there are 3 poles, so we assume that there are 3 0 at infinity, and that is only assumption, right? That is only assumption. Now first we have to draw locate the roots, the poles of the sorry, not roots, is the poles. First we have to locate the poles of our system in S plane. इसको क्या कहते हैं? This is the S plane. Always remember that this is the S plane. What is the S plane? This is the sigma plus j omega. We know that S is equal to sigma plus j omega. Means this is the real part, this is the imaginary part, this is the real part, this is the imaginary part, this is the S plane. Now this is the roots. This is the root s is equal to 0, this is the s is equal to -1, this is equal to s is equal to -3. हमने इसको यहाँ पे लोकेट किया। हमें क्या करें, जब भी हम प्रॉब्लम सॉल्व करेंगे तो हम क्या करें, पहले यहाँ पे कैलकुलेशन करेंगे वन साइड में, और थोड़े स्पेस पे हम इसको ड्रॉ करते जाएंगे। ऐसा नहीं कि आप पहले ऑल मैथमेटिकल कैलकुलेशन यहाँ कीजिए देन रूट लोकस ड्रॉ कीजिए, दैट इज नॉट अ गुड वे। आप क्या कीजिए, जो भी आप कैलकुलेशन करते जाइए उसको इस पे ड्रॉ करते जाइए। उससे क्या होगा, आपको इजी होगा कि आपके नेक्स्ट स्टेप आपका क्या होगा और क्या कौन से फार्मूला आप यूज करेंगे। नाउ आप देखो मैं किस तरह से दोनों को पैरेलल में वर्क करता हूँ। मैं यहाँ पे स्पेस छोड़ा हूँ, यहाँ पे कैलकुलेशन करूँगा और यहाँ पे ड्रॉ करूँगा। सी नाउ व्हाट इज द सी द एग्जिस्टेंस ऑफ रूट लोकस। अब रूट लोकस रियल एक्सिस पे एग्जिस्ट करेगा या नहीं, इसके लिए एक मेथड होता है और उसको देखते हैं किस तरह से रूट लोकस यहाँ पे होगा या नहीं, इस पॉइंट पे होगा या नहीं, या इस रेंज में होगा या नहीं, उसको हमें देखना होगा। तो पहले हम क्या करते हैं, यहाँ पे स्टैंड हियर, जस्ट स्टैंड हियर, एंड आपको क्या देखना है कि आपके राइट साइड में कितने पोल्स एंड जीरो है। नंबर ऑफ पोल्स एंड जीरो इन योर राइट साइड, देयर आर नो पोल्स नो जीरो, मींस root locus cannot exist in this region. We cannot exist, root locus cannot exist in this region. Just means root locus minus zeros के right side में नहीं होगा। Clear? Now move something, move some step in your left side and go at here, this point, stand here and say number of poles or zero in your right side, कितने, वन क्या है, ऑड नंबर। जब ऑड नंबर ऑफ पोल्स और जीरो आपके राइट साइड में होंगे, देन रूट्स आर एग्जिस्ट इन दैट रीजन, मीन्स -1 से 0 के बीच में रूट्स एग्जिस्ट करेंगे, मीन्स यहाँ पे रूट्स एग्जिस्ट करेगा। और अगेन यहाँ पे स्टैंड इन दैट रीजन, कम टू हियर एंड स्टैंड हियर एंड सी राइट साइड में कितने पोल्स एंड जीरो, 2, तो रूट्स यहाँ पे एग्जिस्ट नहीं करेंगे, यहाँ पे रूट्स मेरा एग्जिस्ट करेगा। अगेन यहाँ पे हम खड़े हो गए, क्लियर, यहाँ से मूव किए और हमने देखा क्या, रो नंबर ऑफ पोल्स कितने हैं, 3, 1 2 3, मीन्स रूट्स इधर भी एग्जिस्ट करेंगे, मीन्स इस रीजन में और इस रीजन में रूट्स एग्जिस्ट, रूट लोकस एग्जिस्ट करेगा, बट इस रीजन में रूट लोकस एग्जिस्ट नहीं करेगा। तो पहले मैं इसे रिमूव कर देता हूँ, मीन्स इन दोनों रीजन में रूट लोकस एग्जिस्ट करेगा। अब क्या होता है रूट लोकस में, फर्स्ट वी इंक्रीज द वैल्यू ऑफ के, व्हेन इंक्रीज द, नाउ first 1 second, what is the value of k at pole, we know that, what is the value of k at pole, value of the k at pole is, value of the k at value of the k at pole is 0, we know that। फर्स्ट लेक्चर में मैंने डिस्कस किया पोल पे डीसी गेन की वैल्यू क्या होती है, 0 होती है। ये हमें पता है, सबको पता है कि पोल पे डीसी गेन की वैल्यू 0 होती है और 0 पे डीसी गेन की वैल्यू इन्फिनिटी होती है। इसे मैं थोड़ा लार्ज कर देता हूँ, पोल पे डीसी गेन की वैल्यू 0 होती है। अब हम क्या करेंगे, के की वैल्यू, दिस इज द के, अब के की वैल्यू मैं इंक्रीज करूंगा। नाउ व्हेन वी इंक्रीज द वैल्यू ऑफ के, लाइक k is equal to 0 1 2 3 4 5, then these root start moving in this direction, like minus root -1 start moving like this, okay? Moving like this, and when and these roots start moving in this direction, हमने क्या किया, यहाँ पे वैल्यू ऑफ द की मैंने इंक्रीज किया, हमने क्या किया, वैल्यू ऑफ द की इंक्रीज किया। अगर वैल्यू ऑफ द की इंक्रीज करेंगे तो ये भी रूट मूव करेगा, तो ये रूट्स भी, दिस रूट्स आल्सो स्टार्ट मूविंग। तो क्या ये रूट इधर मूव कर सकता नहीं, क्योंकि यहाँ पे रूट लोकस तो एग्जिस्ट नहीं करेगा, क्योंकि यहाँ पे जो आप खड़े हो गए तो क्या होगा, इवन नंबर ऑफ पोल मिलेंगे, मींस इस रीजन में रूट लोकस एग्जिस्टेंस में नहीं होगा। तो इसके में क्या होगा, 1 सेकंड, जो फोन कॉल, so when we increase the value of k, when we increase the value of k, roots move in this direction, this root start moving in this direction, this root start moving in this direction, and this root start moving in this direction, means going away from here, means I'm using some different color, means I am saying that is the roots, sorry, this roots start moving in this direction. you know, when I increase the value of k, this root, when I increase the value of k, s is equal to minus 3 goes start mode like this in this direction and goes to infinity. This goes to infinity and terminated there is the virtual zero. You can say it imaginary zero or virtual zero. And here value of k is infinity. Terminated at this point. This when we increase the value of k now. Okay. When you increase the value of k here, then this root is starting in this direction and start this root going in this direction, and they are collided at this point, and they split it in two parts. Means this is the breakaway point. Okay, so we have to calculate what is the value of s at this breakaway point. What is the value of s at this breakaway point? What is the value of s? So to calculate the breakaway point, we have some process, and this is the process is breakaway point. Breakaway point can be calculated by help the characteristic equation. It's characteristic equation. Just write the characteristic equation, put the value of your given system, that is s into s plus 1 into s plus 3 is equal to 0. Can we write k is equal to minus s into s square, that is the 4s plus 3. This is nothing but to move k 1 in this direction, that minus 1, and multiply with this quantity, this quantity. Now k is minus s cube plus 4s square 3s cube. Now differentiate this k with respect to the s, differentiate this k with respect to the s, and we get minus, this is the 3s square for 8s, this is the 8s plus 3. Now make del q over del s is equal to 0. Then what happen? The 3s square plus 8s plus 3 become 0. Now what is the roots of this? There are two roots of s. There are two roots of let s1 and s2 are two roots. After solving by help of the calculator, we get the two different roots, that is the 0.45 and minus 2.2. Solve this equation by help of the calculator and get this 2 point. Now see where is the point minus 0.45. Where is this point? Now Locus, see here, minus 0.45. Minus 0.45 located between 0 to 0, between 0 and minus 1. Means this point may be at this here. This is the point of our breakaway point. Okay, this is the breakaway point. Means now, and where is this point? Minus 2.21. See where is minus 2.21? Minus 2.21 something here. Minus 2.21 something here. This is the minus 2.21. Now see here, there is the no root. Means this is the invalid point. Means just remove this point. No need to write here, because this is the invalid point. The root locus cannot exist in this region, and root locus only exists in this region. This is the, so this is the valid breakaway point. Means we can say that this is valid breakaway point, but this is the invalid breakaway point. Means we cannot consider this point for further calculation. We only consider this point. Why it is called breakaway point? Because we know the definition of breakaway point is when roots are moving away from real axis. This is the real axis. This is the real axis. This is the imaginary axis. The roots of locus are moving away from real axis, shifted from real axis to, or root locus shifted from real axis to the imaginary axis, complex plane. Shifted to from real axis to the complex plane. Means from here root locus may goes in this direction, may goes in this direction, may goes in this direction, and also the green roots, this locus may in this direction and this direction. There is multiple way, but what is the exact direction of this root locus? Exact direction of this root locus. Then we have to find what is the direction of root locus. This goes in this direction, or this goes in this direction. This direction may also move. हमें ये कैलकुलेट करना है। तो हम इसको रिमूव करते हैं। सो वी हैव टू कैलकुलेट द डायरेक्शन ऑफ आवर लॉकस। तो यहाँ से जो रूट ब्रेक्स होंगे और वो कहाँ पे जाएंगे, इन्फिनिटी पे ऑब्वियसली। तो इसको हम क्या बोलेंगे, असिम्पटोट्स। क्या बोलेंगे, जो रूट्स ब्रेक और पॉइंट से होते हैं वो, और इन्फिनिटी पे जो रूट्स टर्मिनेट होते हैं वो क्या होते हैं, असिम्पटोट्स। तो हमने पढ़ा था कि असिम्पटोट्स क्या होते हैं, एक टर्म आता है, देयर इज द टर्म ऑफ, देयर इज द asymptotes. What are those? The root locus के वो branch which are terminated at infinity, ऐसे branch जो infinity पे terminate होते हैं उसे हम क्या कहते हैं, asymptotes. Clear? और number of asymptotes हम कैसे calculate करते हैं, number of asymptotes calculated by open loop pole and by help of open loop pole and zero. Means if I say if someone asks what is the number of asymptotes, asymptotes number of asymptotes is p minus z. What is the p, number of poles? What is the number of poles? There are 1 2 3, there are 3 poles here, 1 2 3, this is 3. What is the number of zero? Number of zero is 0, there is no 0, this is the 0, means 3. What is the meaning of this 3? Means there is 3 branch in our root locus which are terminated at infinity. So now see here, one branch started from -3 and goes terminated at infinity. Means one branch terminated at infinity. There is a 2 remaining branch started from this breakaway point and goes and terminated there infinity. This is the asymptotes. Now, first we find what is the centroid. And so what is the centroid, from where asymptotes are started. So we have to calculate if there are difference between pole and zero, then we have to calculate the number of asymptotes. If poles are 3 and 0 are 0, means there are 3 asymptotes, means 3 branches going to terminate in infinity. Then we have to calculate centroid. What is the centroid? We know the centroid, sum of real part of pole minus sum of real part of 0 divided pole minus 0. Sum of real part of pole. What is the sum of real part of pole? That is the 0 minus 1 minus 3. This become minus 4. Sum of this is minus 4. This is the 0. There is no any 0. Pole. Number of pole is 3. Number of 0 is 0. Means this become minus 4 by 3. Minus 4 by 3. Or this is the minus 1.33. Means centroid of our root locus is minus 1.33. Not centroid. This is centroid of root locus, means minus 1.33. Minus 1.33, maybe this is the location of minus 1.33, means less than minus 1. This is, let us assume that this is the location of minus 1.33. Maybe this may be here, this may be here, but I am assuming here. This is the centroid. First of all, we have to calculate angle of asymptotes. Angle of asymptotes. Angle of asymptotes. Asymptotes. Angle of asymptotes is calculated. Angle of asymptotes is calculated by the formula. There is the formula 2q plus 1 multiply with 180 divided with p minus z. P minus z. What is the q? What is the q? Sorry, this is the q here. What is the q? This is the q. What is the q? Q is started from 0 and goes 1, 2, 3 and like this, and limit of q is p minus z minus 1. What is the p? Number of pole. This is the 3. Number of 0. This is the 0 minus 1 means 2. Means q is started from 0 and goes 1 and 2. This is the maximum value of q. 2. This is the maximum value of q. This is the 2. This is the main part. Now, put the value of q. What is the pole in here? We have calculated 2q plus 1 multiply with 180. Now 3 minus 0, because the number of pole is 3 minus 0. This 3 is 160, so this is 180, and this is 60. Now put q is equal to 0 at this point, then angle is at q is equal to 0, theta means angle of asymptote is 60 degree, right? When q is equal to 1, angle of asymptote theta, I say angle of asymptote is theta, angle of asymptote is 180 degree. When q is equal to 2, angle of asymptote theta is 300 degree. Put q is equal to t here and calculate angle of asymptote here, right? Now this value have been calculated. Now draw these angle are started from centroid. From centroid means we have to draw 60 degree angle at this point, minus 1.33, minus 180, minus this point, and 300 degree angle at this point. Means in our root locus, this is the centroid. First draw 300, means as I am saying that this is the 60 degree. This is the just take a pen and pencil and draw a line. This line आप इससे draw करोगे pencil के through. Theta is equal to 60 degree. Now again draw a line here. This is the 180. This is the 180 from here. Then we draw a parallel line with the help of the pencil. This is the theta is equal to 180 degree. अगर इसको हम पेंसिल से ही ड्रॉ करेंगे. ऑलवेज रिमेंबर दैट. ये नहीं कि आप पेन से इसको ड्रॉ करें, हमारे रूट लोकस में इफेक्ट नहीं पड़ना चाहिए. हम पेंसिल से इसको ड्रॉ करेंगे. थीटा यहाँ पे सॉरी ये मेरा थीटा होगा समथिंग. हम थीटा इज इक्वल टू 300 डिग्री पेंसिल से हमने ड्रॉ किया. क्लियर. नो थीटा इज इक्वल टू 60, थीटा इज इक्वल टू 180, थीटा इज इक्वल टू 300 हमने ड्रॉ किया. अब जो यहाँ से ब्रेक भी होगा, जो हमारे एसिम्प्टोट्स होंगे, जो यहाँ से ब्रांच में ब्रेक होगा 2 पार्ट्स में, वो इसको हम क्या कहते हैं, एंगल ऑफ एसिम्प्टोट्स, राइट. और यहाँ से जो ब्रांच स्टार्ट होगा उसको कहेंगे एसिम्प्टोट्स. तो नाउ हमें क्या मिलेगा, वहाँ से डायरेक्शन मिल जाएगा, ये ऐसे मूव करेंगे. क्लियर. इस डायरेक्शन में जाएगा. जब के की वैल्यू हमने इंक्रीज करना स्टार्ट करना तो ब्रेक होने के बाद इस डायरेक्शन में जाएगा. बट ये रेड लाइन मीन्स जो हमारा एसिम्प्टोट है, एंगल ऑफ एसिम्प्टोट को कभी भी क्रॉस नहीं करेगा, इसके पैरेलल में हो जाएगा, इन्फिनिटी भी जाकर. और ये कहाँ पे टर्मिनेट हो जाएगा, के इक्वल टू एट के इक्वल टू इन्फिनिटी पे. बिकॉज के इक्वल टू इन्फिनिटी में इसको क्या मिलेगा, वर्चुअल जीरो. वहीं पे टर्मिनेट हो जाएगा, मीन्स ये इन्फिनिटी पे गोज टू इन्फिनिटी. एंड वहाँ पे वर्चुअल जीरो मिलेगा, वहाँ पे टर्मिनेट होगा, वहाँ पे के की वैल्यू क्या होगी, इन्फिनिटी. वहाँ पे के की वैल्यू क्या होगी, इन्फिनिटी. सिमिलरली लाइक दिस, वर्चुअल जीरो पे टर्मिनेट होगा और के की वैल्यू इन्फिनिटी होगी. सिमिलरली the green branch, this branch is started and goes like this, and parallel to this axis and come like this here, like this and goes parallel. इसको हम पैरेलली ड्रॉ करेंगे और एक कहाँ पे टर्मिनेट होगा, वर्चुअल जीरो पे. वहाँ पे के की वैल्यू क्या होगी, इन्फिनिटी होगी. हमने पढ़ा था कि जीरो पे डीसी गेन की वैल्यू क्या होती है, इन्फिनिटी होती है. तो ये मेरा रूट लोकस डिजाइन हो गया. बट इसके कुछ और पॉइंट्स हम कैलकुलेट करते हैं जो क्वेश्चन में मेरी हेल्पफुल होगा जानकारी के लिए. ना कुछ पॉइंट्स हम यहाँ पे कैलकुलेट करते हैं लेटर. एक्चुअल maybe someone asked what is the value of k at this point, means at breakaway point what is the value of k. Someone may ask also what is the value of k at this point, what is the value of k at this point, what is the value of s at this point. Someone also asks here what is the value of k at this point, what is the value of k and what is the value of s. Just remove this part here. Once again, this is I am writing here at here the value of k is infinity. Clear. यहाँ पे टर्मिनेट होगा, वहाँ पे k की वैल्यू infinity होगी. So someone may ask what is the value of k at this point when breakout. This is nothing but what is this point? This point is the breakout point. We know this is the breakout point. Okay. So what is the breakout point? Definition of breakout point is when the root locus shifted from real axis to the complex plane, तो उस point को क्या कहते हैं, breakaway point कहते हैं. So we have to calculate now this at the breakaway point we know the value of s. At the breakaway point we know the value of s, but at breakaway point we does not know what is the value of k. At this point where the our root locus cross the j omega axis, we does not know what is the value of k. At this point when again our root locus cross the j omega axis, we does not know what is the value of k. Then we have to calculate what is the value of k and s in this point and this point also. Now means breakaway point. To calculate the value of k at breakaway point, we use the magnitude criteria. We use magnitude criteria. Now, what is the magnitude criteria? Magnitude criteria say that. Magnitude criteria say that. This is the magnitude. Magnitude criteria say that if I have an open loop transfer function GSHS and S is equal to S1 lies on root locus, then it must satisfy this condition. It must satisfy the modulus value of open loop transfer function at S is equal to X1 should be means what is the GSSS? GSSS given at S plus 1 into S plus 3. This is known as the magnitude criteria. This is the magnitude criteria. Always remember that this is the magnitude criteria. This modulus value of this is equal to 1. At which point S is equal to S1. Now हमें कहाँ पे कैलकुलेट करना है k की वैल्यू? हमें k की वैल्यू कैलकुलेट करना है S is equal to -0.45. तो S1 की जगह पे क्या लिखेंगे? S1 की जगह पे लिखेंगे -0.45. तो मीन्स S की जगह पे हम क्या पुट करेंगे? -0.45 और इस मॉडुलस वैल्यू को सॉल्व करेंगे तो k की वैल्यू हमें मिलेगी दैट इज द 0.63. k यहाँ पे कभी भी नेगेटिव नहीं होगा क्योंकि हमारे क्वेश्चन में मेंशन था k is always greater than 0 और less than infinity. मीन्स क्वेश्चन में मेंशन है तो k की वैल्यू यहाँ पे कभी भी नेगेटिव नहीं होगी. और यहाँ भी आप देख सकते हैं मॉडुलस है तो मॉडुलस के बाहर कभी भी नेगेटिव साइन नहीं होता. तो k की वैल्यू 0. जब आप इसे सॉल्व कीजिएगा इसको s की जगह पे आप इसे यहाँ पुट कीजिए एंड सॉल्व कीजिए देन आपको मिलेगा k is equal to 0.63. means at this point value of DC gain is 0.63. clear? This is the approximate value or maybe 0.63. This is the approximate value. Now we have to calculate what the value of k at this point. Now to see here the root locus are crossing the j omega axis. We know these root locus are crossing at this point means j omega axis. Then we can say that j omega axis means we use the RS criteria, means RH table. We use the Routh-Hargis table, right, to find the value of k at this point. In Routh-Hargis table, we know that at this point system is marginally stable. Pole are located at j omega axis, and system is marginally stable. Okay. Or for in Routh-Hargis criteria for marginal stability, we have to calculate in Routh RS table. First we create the RS table. What is the RS table created by 1 plus GSHS is equal to 0. Now 1 plus k into s, k divided with s plus 1 into s plus 3 equal to 0. We can calculate here s cube plus this become 4s, right? 4s square plus this become 3s plus k is equal to 0. Now draw the RH table here. RH table is s cube s square s power 1 s power 0, and we take this is a 1, 4 is written here, 4, this is 3 written here, this is the k. Now 4 multiply with 3 12, k multiply with 1 k divided with 4 0, this multiply with this quantity, this multiply with 0 0 means this become k. Now for a system to be marginally stable, the odd power of s term means this row should be 0. All term of this row should be 0. Means this quantity should be 0. This quantity should be 0. Clear? Means k is equal to 12. And here say that the k should be greater than 0. Clear? K should be greater than 0. Means this s to the power g, s to the power means even power of s cannot be equal to 0, means k should be greater than 0, k is equal to 12 from here. Okay. Now system is marginally stable. This set means at this condition, when this row becomes 0, like this row becomes 0, 0 is here, and k, we put k is equal to 12 here, then system is marginally stable. Now then at this point value of k is 12. हम कैसे कैलकुलेट करेंगे यहाँ पे उस रो को जीरो करेंगे जिसका एस टू दी का एस का ऑड पावर, एस का जो भी जिस रो में एस के ऑड पावर है वो जीरो होनी चाहिए, तो इसको हमने जीरो किया, वहाँ से जो वैल्यू ऑफ के मिली उसको मैंने कैलकुलेट किया, और दिस इज द वैल्यू ऑफ के पुट इन here. Means value of the k at this point is 12, value of the k at this point is also 12, because at this point root are also crossing the geometric axis. Then we have to find what is the value of s at this point. What is the value of s at this point? This can be calculated from now. Write the equation of this line. We can write the equation. This is known as the auxiliary equation. Now we know the auxiliary equation. Auxiliary equation written by help of this line. 4 multiply with s square. 4 multiply with s square plus k into s to the power 1 नहीं होगा, इससे पावर में दो पावर कम होना चाहिए, लेस देन 2, तो s to the power 0 होगा, राइट. difference between power of this two term is should be 2, means this should be s to the power 0, means s to the power 0 means 1, means we can write like this. This is the auxiliary equation. What is the value of k? We already calculated the value of k is 12. What the value of k is 12, this will come here. S square is equal to minus 3, means calculate s is equal to plus minus j root 3, means we know s is equal to j omega. Compare plus minus j omega, compare this equation, means omega is equal to root 3. Clear? We radian per second, means by help of this calculation we have calculated the value of s at this point is under root 3. Value of s at this point is plus j root 3, and value of s at this point is minus j root 3. Now value of omega, value of omega at this point is under root 3 radian per second. Value of omega is angular frequency under root 3 radian per second. Yeah. Value of omega at this point is under root 3 radian per second. Value of omega at this point is 3 radian per second. Now we have calculated all the quantity here. Now in our question asked that, take some basic concept here. I am going to discuss some trick here. Now see this point here. See this equation. This is the third order equation here. Now write some trick here to calculate the breakaway point at angle and something like value of k. Some trick are here. We can determine the stability of the system here also, and also by help of the Locus. See, there is the internal term. This is the internal product, or this is the external term. These two are external term. Clear? External. This is the, I say this is the internal term. This is the external term of this equation. Now, if the inner product, means 4 multiply with 3 equal to the external product 1 multiply with k, then system is marginally stable. Always remember that. If inner product is greater than the outer product, then system is stable. If inner product is less than the outer product, then system is unstable. Any system, this is true for any system, but limit is that the order of our characteristic equations should be 3. Means this cannot be applicable for s to the power 4. This trick is only applicable for s to the power 3. Clear? Means now see here, for marginal stability of the the system should be marginally stable, means root are located at this point, then system is marginally stable. And for marginally stable, what is the value of k? That should be 12. And we have calculated by r stable, the value of k is 12. Means by this trick, we can easily find the value of k. That should be 12. Okay, the value of k, that should be 12. Now at this point, the value of k is 12. Now in our question asked that, it asked that, I'm going to take this image, this complete image, to write some solve there. I need some image here. This is a copy that image, take this image, download and paste this image here. That is the paste. Okay. Now in our question, that given that, this is the question given that, find the gain margin. We have draw the root locus, right? In question that is asking, find the gain margin of the system when value of k is equal to 6. Now see here, value of k is equal to 6. Now gain margin of the system, the formula of gain margin is equal to k marginal, when value of k when system is marginal stable, divided with k desired. K desired given in our question, means k desired is given on question given that at k is equal to 6, means this is the k desired. So at this point I am going to calculate the value, means k desired is equal to 6. What is the value of k when system is marginal stable? We know system is marginal stable at this point, means value of the k at this point is 12. So when we have to put 12, and this is the gain margin. Now gain margin of system is 2. Now we have to take, generally gain margin को dB में express करते हैं, तो we have to take gain margin in dB, then we clear 20 log base to 10 to, this is equal to plus 6.03. This is the answer of the question. This is asking the what is the gain margin, but now say there is a general question here. This is a very important point I am discussing here, very important. Just make a notes for this point here. Now in mathematics, when we convert a normal unit into the dB, then we use 10 log. For example, if I have a x is the number, let x is the number, I want to convert this number in dB, then what is how we write x in dB equal to 10 log base 10 into x. Always we taking here 10, but here I am taking 20. Question is why I am taking 20? Why not I am writing this gain margin? Why not I am writing this gain margin 10 log base 10 to, why not I am writing like this? Why I am writing 20 here? Now see the explanation of this doubt. Maybe someone asked, you may know, this is the very simple trick here, very simple concept here. Now see, dB is the unit of power. What is the dB? dB is unit of power. Means if someone asked you convert 2 watt into how much dB, into dB, and 2 volt is equal to how much dB, or 2 ampere is equal to how much dB, or someone say 2 is equal to how much dB. Means these two is unitless quantity. These have the unit ampere, this have unit volt, this have unit watt. When we know the relation between power and amplitude, P is equal to V square by R or I square R. Okay. We say that P directly proportional to the V square, and P directly proportional to the I square. Okay. Means if I am saying If I want to convert this quantity p into the power, then we write 20 log p, and we can also write 10 log p, sorry, 10 log v, 10 log v square, because power is directly proportional to v square. This goes to here, and this becomes 20 log v. Yes, this becomes 20 log v. This what is the v? This is the voltage here. Now, in our electronics, there is the voltage is v naught sine omega t. Means this is also voltage, or this is the amplitude of this signal. Means amplitude means if there is the amplitude, means if in our log, if this quantity is power, then we take 20, then we take 10. If that quantity is not a power, then we take 20 log x. If this is not a power, this is voltage and current or amplitude, then we take 20 log by help of this derivation. Means let convert this part here. Means someone asks what is the dV value of 2 watt, then we write 10 log 2. Why I am using 10 log? Because this is the power watt, but if this is the voltage, then I am writing 20 log 2. This is the 3 dB, this is the nearly 6 dB, this is the nearly 3 dB approximate value. This is ampere current, this also can be write 2, or this approximate 6 dB, and this is the 2, this is the unitless quantity 2, and unitless quantity this also can be write as 20 log 2. Always remember this part, plus 6 dB. Always remember this very important concept is here. Why I am writing 20 here. Now see here, what is the unit of this 2? Now what is the unit of this? K is the DC gain, this is the unitless quantity. Again desire gain, this is the 6, this is also a unitless quantity, means the ratio of two unitless quantity is a unitless quantity, means gain margin here is the unitless quantity. Now if I have a unitless quantity and I want to convert that quantity in dV, then we have to take, this is a unitless quantity and I want to convert this quantity in dV, we have to take 20. Okay, if this is the power, then we take the 10, means we take 20 log 2, because this is a unitless quantity. This may be amplitude, this may be voltage, this may be some other things. So we take the 20 log 2, or this becomes 60. This question is solved here. Our gain margin of the system is 60. Now I am going to discuss some here point here. Now see here, at this point I am going to discuss something more than this question. Now see here, when we increase the value of k from 0 to 0 to some value 1 to 3 for root locus cosine, means poles are moving from here to here at some value greater than k, our poles are located at this point. At k is equal to 12, our poles are located at this point. At k is equal to less than 12, our poles are located at this point. Means when k is equal to, see here, when k is equal to 12, see here, when k is equal to 12, our poles are located at this point and this point. Our poles are located at this point and at this point, means j omega axis, and something k here located, one pole may be located at this point, clear? At k is equal to 12. When the pole are located at imaginary axis, then system is marginal stable, clear? When the poles are goes, means when k is equal to 12, k more than 12, then poles may be k is equal to 15, right? K is equal to 15, at poles may be at this location, at this location, right? Means poles are right side of j omega axis, something like here, at k greater than 12, something like here, and this system is unstable because poles are located in right side of j omega axis. And when k value of k is less than 12, then our pole may be located at this point. At this point means pole may be this point and this point, and this system is a stable system. Okay, means by observing, yeah, investigating the root locus, we can say that by using this concept, we can say that when k is equal to 12, the system is marginal stable. Marginal stable. Clear? When the value of k is greater than 12, when the value of k is greater than 12, our poles are goes like this. Means k is equal k greater than 12, our system is unstable. Unstable. And when value of k greater than 0 and less than 12, then system is stable. Okay? System is stable. Right? This is the or this same thing I have calculated by help of some tricks I have already mentioned here. Now see here, k value less than system is stable, k is greater than system is unstable. Means by help of this type of auxiliary equation we can easily calculate this type of equation we can easily calculate whether the system is stable or not. And for that calculation we need a lot of calculation is here for root locus. Clear? I have designed here. Now let us use MATLAB to design our problem. Now in our problem it is given that this is our open loop transfer function. This is our open loop transfer function. Now this is our open loop transfer function. I am going to write this open loop transfer function in MATLAB. In MATLAB and see how is the plot to look like. Now I am going right here. See here at this point I am writing our program, and this h is this s is nothing. We put the value of k is equal to 1 for what here. Reason is that in MATLAB we have to define each and every variable. I just put value of k is 1 here, right? By default. Or this s into s plus 1 s plus 3, and this is the written s into s plus 1 s plus 3, or that is written in our MATLAB. Okay, this is written on MATLAB. And when I run this program, then I am getting a command with this is our transfer function h, or this is our root locus. Means this command generate our root locus at this command. This command used to generate our root locus here. Now see, this is the root locus generated by our MATLAB, and this is the root locus generated by our some design. We have designed some root locus by help of some mathematical calculation and all that. Now see the difference between these to the root locus going smooth like this. Our this root locus going downward, and root locus started from this point and goes and terminated at infinity. Now see here at this point, what is the gain of the system at k 0 and pole is 0. Now see here, our pole is 0 and gain of the system is 0. Now at this point, see what is the pole of the system. This is the pole. This is the, I say this is -3 pole, and our gain is 0. Now here our pole is -3, our gain is 0, and this root goes to infinity, and this root goes to infinity. Now when we at this point, similarly, our if I clicking here, I see gain of the system is gain of the system is 0, and our poles is -1. Here poles is -1, and gain of the system is 0 with k is equal to 0. Now see at the breakout point, when I'm clicking on breakout point, now see here what is the gain 0.6. This sorry, zero, this is not sorry, this should be real number, right? Breakout point is 0. Something, sorry, this should be okay. 0. Little bit moving that direction. I'm getting this is the breakaway point here. At breakaway point, I am calculating here our poles and 0. We see that is a something point is gain our gain is at this 1.6, and this is, so let's just move with this. This is very small window, I cannot able to find. This is the poles, this is the poles little bit different here, but due to some calculation you see, but the poles are nearly equal to this point. This is our breakaway point. Now let delete this part, let delete this part, and this part also, and this part also. Now see here, our at this point what happened, this our gain is 11 point something, and our in our calculation this get 12. Well, this is something we move with this. This is completely imaginary, means if I exactly click at this point, this is the at 12, and at 12 the gain is equal to 12, and pole is at this point is imaginary. This is very small, means this is the imaginary, and here our pole is imaginary. What is the value of under root 3? 1.73, means this point is 1.73 something, means this is our omega m, means natural frequency at this point. This is the frequency in radian per second 1.73, and also frequency in radian 1.73. When we move our system in this location, now see here at this point, poles are complex, but this is the positive, means poles lies in right half of S plane, right half of S plane, means from here to here our system become unstable. But here at this point our system poles are in complete imaginary. This is the marginal stable, and here our poles are, see that this negative sign is here, means poles located in right half, left half of S plane. Our system is stable. Okay, now we have observed that all the different parts of our problem, and we compare our root locus which have designed by some mathematical process with the MATLAB program. Thank you very much.